Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrell's Algebra 2 class. Today we're going to talk about graphing absolute value functions. And I'm going to give you a little twist on what most people would teach, okay? Most people, just so you understand, will make you make a table, okay? You can make a table of values using the Morrell 5, but it's not recommended. And I'm going to tell you why it's not recommended, guys. When you are making a table for an absolute value function, okay, let's say you use the Morrell 5. Sometimes the Morrell 5 does not give you the full shape of the absolute value. An absolute value equation has a V shape. So this is what ends up happening a lot of times to people who just use the Morrell 5 and they plug in the tables. They'll get a point here and here and here and here and here, and they'll never have the V part. And they'll go, okay, this is the graph. I did the Morrell 5. I'm done. No. That's the problem with making a table. Sometimes the Morrell 5 isn't enough. And you got to start going either to the left or to the right so that you can get that V-shaped pattern. So I have seen situations where you need 10, 11, 8, 9 different points before you get that V shape. Does that sound like any fun at all? No, not at all. Another thing that people will teach you will be shifts of the graph. If you see here this y equals a times x minus h plus k, we're going to go over this in detail tomorrow, I promise you, but just to give you a little bit of a heads up. The a is going to determine how wide or narrow the graph is, and it's also going to determine whether it goes up or down. If a is negative, it will be pointing down. If a is positive, it would be pointing up. The h, okay? The h is a horizontal shift, a shift to the left or to the right. And notice that it's minus here, so it's opposite. If I have x minus 2, I'm shifting to the right two values. If I have x plus 2, I'm shifting to the left 2 values. It's opposite. And then the k determines if it goes up or down. If it goes up or down, you shift the graph upwards or downwards. This is really cool. It's really awesome. It's really powerful, but still not as efficient as the way I'm going to teach you today. All right? So let me show you the way I'm going to teach you today. Then I'll show you a little quick example of how to shift the graph to prepare you for tomorrow. And then you guys can decide what you want. Okay? The way I'm going to teach it today, guys, is you're going to use the vertex and slope method. This isn't in many books, but it's in my brain, so I'm going to share it with you guys. The vertex is the HK that I was just talking about. The H and the K, that becomes the vertex. What is the vertex? The vertex is this point right here. It's the lowest point or the highest point of the absolute value function, depending on whether or not it is pointing down or upwards. So it's called the max or the minimum. If I have a V shape that's going up, that is my minimum. It's the lowest value. If I have an absolute value that is pointing down, that is my max. It is my maximum value. It is the highest point on the graph. Okay, so that's what I'm going to find first, the HK. Yes, sir. Yes, the H is inside the absolute value. The K is outside the absolute value. If you let me teach it, I will answer all of these questions. Thank you very much. Now, I just lost my train of thought. Okay, no worries, no worries. So I have my vertex, which is HK. And then my slope is the A. I'm going to use that as the slope. Okay? So let's get right to it. What is your vertex here? No, it is not -3. Remember what I told you. That comes from x minus h. So if it's x minus 3, what is the h there? A positive 3. It's always opposite, guys. And what's my k? Okay, so guys, go ahead and graph 3.3, 2. 1, 2, 3, 1, 2. That is my vertex. In front of the absolute value, what do I have in front of here? An invisible 1. Is that positive or negative? So is it going to point upwards or downwards? upwards. If it's positive, it points upwards. If it's negative, it points downwards. Now, what's my slope? If that's a 1, what's my slope? Okay, here's the magic. Go up 1 over 1 to the right, up 1 over 1 to the left. Up 1 over 1 to the right, up 1 over 1 to the left. You are done. You graphed your absolute value equation. No table, no shifting, nothing. Now, for those curious minds out there, oh, what do you do? How do you do with the shifting? We're going to talk about shifting tomorrow. However, real quick, this absolute value function, this is what's called the absolute value function in vertex form. If I have just a regular standard form, it's y equals ax. You make a quick table with the values 1, 0, and negative 1. Okay? In this particular case, my a was 1. So I have y equals 1 times the absolute value of x. When x is 1, y is 1. When x is 0, y is 0. When x is negative 1, y is 1. So my original graph, this is called a parent function. That is the original absolute value function. It can get shifted from there, but that is the parent graph. I would go 0, 0, 1, 1, negative 1, 1, and it goes like this. However, according to this graph, it's x minus 3, so I have to shift it 3 to the right and 2 up. So I go 1, 2, 3, up 1, 2. 1, 2, 3, up 1, 2. 1, 2, 3, up 1, 2. And that's your graph. So shifting is no problem. There's no issues. There's no problems with it. It's nice and easy. But why would you want to do 2 graphs? Why would you want to make it more difficult for yourself? Hands down, for absolute value, this doesn't work for parabolas. For absolute value, this is the way to go. Find your vertex, follow your slope to the left and to the right. Sir? The y is this, brother. Oh, sorry, that's a 1. My bad. Thank you. Yes, sir. If you let me teach, I'll show you all sorts of different examples. Thank you very much. Okay. Number 2, what's my vertex? 0, negative 3. That stays the same. The only one that's opposite is the h. So I go to 0, negative 3. 0, negative 1, 2, 3. What's my slope? Yeah, my a is 1 here. So I go up 1 over 1 to the right, up 1 over 1 to the left. Up 1 over 1 to the right, up 1 over 1 to the left. Bing, bang, boom, I'm done. Tell me that isn't boss. So much easier than making a table, so much easier than shifting. But this only works, my brothers, for absolute value. Trust me, I have a nice, easy way for parabolas as well, but that takes a little bit of calculation. This is no calculation. You just read, find the HK, follow the slope. Yes, sir.
So that goes on forever?
Yes, it goes on forever. That's why I put arrows. Thank you, sir. Great question. Yes, sir. Yes, we're going to do several examples now. I just want to go ahead and show you the easy stuff so we could walk before we run. Excuse me for one. Okay, thank you. Sorry about that little pause. All right. What's my vertex here? 3, 1. Very good. It's always opposite. So I go 1, 2, 3, 1. What's my slope? My a is 1. So up 1 over 1 to the right, up 1 over 1 to the left, up 1 over 1 to the right, up 1 over 1 to the left. Bing, bang, boom. We're done. Not bad, right? Okay, now, let's complicate things a little bit. What's the vertex here for number 4, my brothers? -1, -5. Beautiful, gentlemen, beautiful. So -1, let me scroll down a little bit. -1, 1, 2, 3, 4, 5. What's my slope, guys? -2 over 1, very good. So now I got to go down 1, 2 over 1, down 1, 2 over 1, down 1, 2 over 1, down 1, 2 over 1. You follow it to the left and to the right. And guess what? You're done. And remember what I told you. The A was negative, right? So I had to be pointing down, correct? And there it is. Talk to me, guys. Some of you are giving me faces like you're not understanding it. This is my job and my pleasure. How can I help you, brothers? Please. This is what I do. Yes, sir, my brother. Okay, if the x was squared, I'm not being sarcastic, then it wouldn't be an absolute value anymore, my brother. Then it'd be a quadratic, and we're going to learn all about that tomorrow. Thank you for asking and caring. Talk to me a moment. Yes, sir, my brother. Okay. Okay, look. You have my -1, -5. So -1, 1, 2, 3, 4, 5. Slope, bro. Fall over run if it's negative. Or rise over run. It's slope. But now, since it's an absolute value, we have a V shape. So I got to go to the right and to the left, my brother. So I'm going to go down 1, 2 over 1 to the right. Down 1, 2 over 1 to the left. Then from my next point, down 1, 2 over 1 to the right. Down 1, 2 over 1 to the left. And I can keep doing that forever. But all I need is 5 points. Thank you for your honesty. Does that make sense, gentlemen? Promise? Okay, do some more. Okay, I got 5x plus 10 minus 2. Wait a second. Mr. Morrow, this is a little bit different. And the other ones, I didn't have anything in front of this x. So before I tell you the answer, what do you guys think I would do here? Yes, sir, my brother.
Add 2 and
No, but you're trying, and I'm proud of you. Yeah, kind of. It's factor by 5. So great, great, and great. Guys, you're going to factor out of 5. When you factor something out, you're dividing that number. But you have to show the number that you divided. So I'm dividing 5 from here and from here. So this is y equals the 5 that I divided out. And what's 5x divided by 5? What's 10 divided by 5? And then minus 2. What's my vertex, my brothers? -2. -2 is beautiful. So -2, -2. What's my slope, my brothers? 5 over 1. So from here I'm going to go up 1, 2, 3, 4, 5, 1 to the right. Up 1, 2, 3, 4, 5, 1 to the left. Up 1, 2, 3, 4, 5, 1 to the right. Up 1, 2, 3, 4, 5, 1 to the left. And I am done. Do you notice how this is a lot narrower than the other ones? They're not as wide. We're going to learn about that tomorrow, but just so you understand, the A, as the A gets larger and larger, the graph gets narrower and narrower. It's called a vertical stretch. But we'll talk about that more tomorrow, but I want you to understand why this is happening. Does that make sense, boys? Now we're going to separate the A's from the B's here. Okay. Y equals absolute value of 0.5x minus 2 plus 1. Okay, let's think about this. What do I got to factor out? 0.5, okay? So I'm going to divide 0.5 to both sides. But how can I represent 0.5 as a fraction? Okay, good. So I have 1/2. What's 0.5x divided by 0.5? X. What's 2 divided by 0.5? It's 4, guys. 0.5 into 2. 1 to the right, 1 to the right. That goes in 4 times. Be careful. Or you could have done 2 divided by 1/2. Stay, change, flip, and it would have been 4 as well. Either way, I just want to show you that when you factor something out, you're dividing every single term that you're factoring by that same value. So this is 1/2, bless you, of x minus 4 plus 1. What's my vertex, brothers? 4, 1, very good. So 1, 2, 3, 4, 1. What is my slope, my brothers? So I'm going to go up 1, 1, 2 to the right. 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 Do you guys notice how this is a lot wider? Because what happens here is if the a is a fraction, it gets wider. If a is a whole number, it gets narrower. But we will talk about all of those rules mañana. Does anyone have any questions about this, guys? Because I think I just destroyed this lesson.
Good, sir.
You guys got it?
Yes, sir.
God bless you all. Thank you very much. Hope you learned a lot. Have a great day.